Hey there again, my friends. Welcome to Sciencing Around, and this time I'm starting with optics. Yes, I'm starting with optics, and now I'm starting with wave optics. Now, what is wave optics? Let's see. Wave optics is nothing but the nature of photon or nature of light in the form of wave. In the form of waves, that's now we're gonna see. Let's see Huygens principle. First of all, this video is basic for basic wave optics. So Huygens principle says that all points on primary wavefronts are source of light which travels and creates disturbances called as secondary disturbances, and tangentially to all that gives us position of the new wavefront. Let me tell you how does the light works. What does Mr. Huygens says that if this is the source of light, okay wait, my back page will get totally spoiled. This is the wave source of light, then light travels in three-dimensional spheres. That is nothing but wave fronts. And normal to this is nothing but wave normal. This is the first wavefront, second wavefront, third, fourth, fifth, and all that stuff. Now, interference. Superposition. First, what is superposition? Two sources are said to be coherent if their frequencies are same and constant phase difference. They should be in the same phase. That's in same direction, or I must say. And what is superposition? The meeting of two waves is the superposition. Now, what is constructive interference is when two wave trends interfere in same phase. When they are in same phase or in same direction or in same angle of phase, then they are coherent. They are constructive interference, and when phase difference is 2n in the multiple of pi, that is when in even when it's even multiple of pi, then of its phase difference, then it's constructive interference, and path difference is n lambda, where n is 0 to infinity. And what is the amplitude, which is maximum amplitude of the wave? Now, what is wave? Wave is something like this, and this is the amplitude. So the maximum amplitude, no, this is the amplitude, I'm sorry. The maximum amplitude would be a1 plus a2 if the two amplitudes are given. If the two amplitudes are given, then maximum is a1 plus a2, and if two of those intensities given, then under root of I1 plus under root of I2 the whole square. Now, what is destructive interference? When two waveplanes interfere in opposite phase. Phase difference is some odd number of pi, that is 2n minus 1 pi, and path difference is 2n minus 1 upon 2 times lambda, that is 2n minus 1 lambda by 2, where n is 1, 2, 3, anything. Minimum amplitude is the difference of the two amplitudes, and minimum intensity is under root of I1 minus under root of I2 the whole square. We get bright and dark bands called as fringe, not fridge. Lol. Sorry, not fridge. We get by this we can get the one dark band, one bright band, one dark band, one bright band, and something else. That is fringe. Now I think we are on the last part, of the basics, especially. Superimposition or interference respects the conservation of energy. That is, its initial energy equals to I1 plus I2, and final energy equals to I max plus I min divided by 2. That's it. I think for now this video is too small, but I hope you can cope up with it, because it's just basics. In my next video I would be teaching you this fucking thing, that is Young's double slit experiment, the most important part of optics. Young's double slit experiment. So see you soon, guys. Happy sciencing.